All right, so today what we're going to do is we're going to start our last new lesson before your test that you have Tuesday. So what you need to do is get your book and open it up to page 194 or 193, whatever there's an open page. And what you're going to do is I want you to do this warm-up. I want you to find me the rate of change for f of x and g of x, all right? And then I want you to tell me which function has a greater rate of change over the interval, and I want both of their intervals to 5, all right? So pause the video and then turn back on once you have your answer. All right, so here we go. So f of x, this is a linear function, which means rate of change. All right, this right here, rate of change, is another way of saying slope. So this right here, 16.1, that's your rate of change or your slope. I'm just going to call it ROC is 16.1. All right, and then your rate of change for this is an exponential function, which means that you are going to need your coordinates. So you're going to need 2 comma something and 5 comma something. All right, so we need their corresponding y values. So what you're going to need is your graphing calculator, go to y equals, type your function in, and then go second table, and that's where you're going to get 2, which is 9. Ooh, I apologize. I don't know why this is highlighting, but 9.72, that's your 2 value, and then 5 is 56.68. 56.68. So now you're going to find your slope. So you're going to go minus minus. So 19.72 minus 56.68 over 2 minus 5. I'm going to put my work down here. In my denominator, I'm going to have negative 3. In my numerator, I got to go and calculate this. What is it? 19. Was it 19 or shoot? I think I wrote that down wrong. No, it's 9,999. So let's get rid of that. It's 9.71 or 72. So apologize, a lot easier not doing this on my book, but here we go. 9.72 minus 56.68, and you're going to get negative 46.96 over 3. So we'll divide this by negative 3, and you're going to get approximately 15.65 over 1. So this is your simplified slope. Here's your simplified slope for f of x. Which one has a greater one? And your answer is f of x has a greater ROC. Now, this is today's lesson. Will this always be true? And the answer is no. Because, as we talked about yesterday, when we compare linear functions, all right, and then exponential, at first linear may have a greater rate of change, but as time goes on, all right, there's going to be a point where your exponential beats out your linear, which means that it's always going to be growing faster. So the answer is no, it's not always going to be true. Now, I have no idea why it keeps highlighting the screen. Bear with me. We're going to go through a couple examples, and then you're going to have time to work in class and get your review done. So here we go. Today we're going to determine when a linear or exponential function will increase or decrease faster. And that's going to be using our calculator. And we're going to determine where one function value exceeds or gets larger than the other. So to do that, we're going to start on page 195. Now I know this is for sure. So what we're going to do is I want you to put both of these functions, this function f of x and g of x, into your y equals. So go to y equals, clear out whatever you have, and we're going to type these in. So 4x minus 5 and 4 to the x, so exponent x, and then minus 5. So again, those functions look very, 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 very similar, but they're not. All right, so once you have them both in, we're going to go second graph, and we want to go to the table. And we're going to write down the values for both functions. So this is going to be f of x here. All right, and this is going to be g of x. We're going to write down -2 for both of them, -1, 0, 1, 2. So for f of x, let's write that down. That's all your y1s in your table. All right, so we have negative 13, negative 9, negative 5, negative 1, 3, and then 7. And that's the last one that we can fit on here because I just wanted to go from negative 2 to 3. Now, I chose these. I just chose these. You could have chosen whatever, but we're going to choose these same ones. Now, g of x, all right, which is y2, its y values are negative 4.938. Negative 1 is negative 4.75. 0 is negative 4. 1 is negative 1. 2 is 11. And 3 is 59. Now, it says graph. So I'm going to graph this f of x function in this yellow. All right, so this f of x, if you look at it, f of x is linear. So we're going to get a line here. Now, you can graph these points, or you could just graph 4x minus 5 the way you would. Start down 5, and then do your slope. Up 4 over 1, up 4 over 1, up 4 over 1, up 4 over 1. And then reverse your slope, and bam. All right, there's your linear function. Now, the second one, this is this guy. This is exponential. So for this one, you will need your graph in your table. But for me, all right, if you look at this, that minus 5 is your k value. So that's your asymptote. So at negative 5, which is right here, you're going to have an asymptote, which means that your graph is not going to go any lower than negative 5. All right, so if I do some of these points like 0, negative 4, all right, 1, negative 1, and then 2, 11, that's all the way up here. And then if you get some of the negative ones, like you get negative 1, negative 4 point something, negative 4. So what you're going to notice is there's your exponential, and it rides along this, and it shoots up like that. So, again, my graph, if you look at it, is not the best. Again, I'm using my computer, but it says we graph both of them. Compare the rates of change of each function. Well, if you notice it at first, all right, the rate of change for our linear is constant. It's the same. It's 4. All right, but your exponential, it starts slow, 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 slow. And at this point right here, I don't know if you notice on your graph, but this is where they were the same. All right, they were the same at x equals 1. They were 1, negative 1. That's where they were the same. And at that point, this point right here, that's where the exponential grew faster than the linear function. And that's what we're doing today. We're going to figure out where they are the same. All right, because at that point where they're the same, one function went faster than the other. And then after they're the same, the other function is going to take its place and then be the fastest growing function. So what we'd say is compare the rate of change. So linear grew faster until until x equals 1, then exponential grew faster. Because at this point, at 1, negative 1, where x is 1, that's where they were the same. And after that, one will be faster than the other. The exponential will. So that will always happen. Exponential will always grow faster than the linear after the point where they're the same. So example 2 on the next page, I don't know if it's 196 or 197. All right, you're going to see this. At approximately what point does f of x exceed the value of g of x? Now, exceed means beats. So beat, or really goes higher. And this is talking about finding where they're the same or close to being the same, and then one exceeds the other. So if you look, f of x is exponential and g of x is linear. So it says, at what point does the exponential function beat the linear? So what we're going to do is go back to our calculator. So turn your calculator on. And we're going to go back to y equals, and we're going to clear out both functions. All right? So let's make f of x y1. All right, and that's your exponential. So 2 parentheses 4 raised to the, now if you see it's raised to the x divided by 20, we got to go parentheses, x divided by 20, close your parentheses, and then you go to your second function, that's g of x, that's y2, so y2, and that's 0.5x. Now we'll go second table, and this is where we're going to go. So now what we're going to do is we want to see when does f of x, which is the exponential, which is our y1, when does it beat our g of x? Well, if you look right now where we left off in our graph, -2, y1 is greater than y2, which means the exponential is greater than the linear. We want to see when it first happens. So if you look, I keep going back, and that's not beating it. All right, let's see. Let's keep going. Could be that it just always is beating it. All right, so we're getting close to it, and it's going to be right about here. You see here at 7, all right, and this is really at 6. 6 between these two, you're going to realize that 6 and 7, and I probably should have put them in differently. I should have put the linear first and then the exponential section second. If you look, this is where the one beats the other. It's right here at x equals 6. At x equals 6, that's where one function exceeds the other. Because it says, when does the value of f of x exceed g of x? Well, it really exceeds it from x equals 6 and below. So smaller below, smaller x values. So that one might be a little confusing. But really, what you want to do, if you wanted to really see it, nope. My graph is still showing me stuff from before. Hold on, let me turn off my scatter plot. I apologize. Come on, man. Scatter plot. I'm going to turn off this thing. Let's do this. Oh, boy. -10. I apologize. You shouldn't have to do this. It's just me. All right, let's see. So this first graph was the first one we put in. This is your exponential. And then this next one is your linear. All right. Now, if you look, all right, you can see right here that the linear starts off ahead and then the exponential starts off ahead and then linear starts to take its place. So what I'm going to do is expand my window, and this is what it's talking about here. I'm going to make this like 50. Let's really see if I can see it happen. So here's your exponential. Boom, look at that sucker take off. Now here's your linear. Here's that guy. So now we need to see more y max. So let's make this 50. All right, so if I look here, boom, see that sucker go up. There's my linear. So if you look, the exponential starts off ahead of the linear. Then it touches each other, and then the linear now exceeds the exponential. And then at this point again, this is where the exponential will then take its final leap where it grew the fastest. So it says, at approximately what point does f of x exceed the value of g of x? Well, here's the deal. We actually want to find the second point of intersection. So we're going to go to our window, all right? And since our max was 50, when I go back to my table, I want to look at x values that are like, I don't know, like 20, 25. So I'm going to go second window, and I'm going to go and start at like 20. And I'm going to see when that happens. So when does the y1 beat the y2? Now if you see it's like 8 and 10, y1 is starting to get closer. And it exceeds it right here at not x equals 6, it's x equals 29. And I apologize for that. I had to look at that graph to really see that the exponential started off ahead and then the linear beat it. And then at 29, that's where your exponential beat the height of your linear function. All right. So here's our last one. So example 3, it says Lane has been offered a job where 2 salary options, similar to what we were doing yesterday. The first option is modeled by the function f of x. This is a linear function. All right, where f of x is in her salary the f of x or y is their salary in dollars after x years. The second option is g of x, which is exponential, where again, y is their salary and x is years. If Lena is hoping to keep this position for at least 5 years, which salary option should she choose? So what we're going to do here is we can put 5 into each equation and get its y value. Or what we can do is we can put both these equations in here, 500x plus 31000, and then your second option, 29000 parentheses 1.04 raised to the x power. All right, what I'm going to do is I'm going to go back to my table set and I'm going to have it start at 0, because what I really want is I want the 5th year. I could have had it start at 5, but I'm going to go back to 0, and now I go second table. So again, y1 is that one, y2 is this one. So we want 5 years. So we want to know when x equals 5, which has a greater y value. So x equals 5, boom, 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 boom. And if you look, here's y1, this is your linear, 33,500, and here's y2, 35,280. So which one's more? It's g of x, which is your y2. G of x, and that's the position you should have for 5 years, because your salary equals 35,283. You say that? So it says support your answer with a graph, but you know what? Graph is unnecessary. What you really need is to just know these values here. So this is what I'm going to have you do now. Now that you've kind of seen this, I'm going to have you and the partner that you're sitting next to work on page, I believe it's either 198 or 199. I think it's 199, as you can see down here. And you are going to work on 1 through 10, and your answers are in that answer packet, that answer key that I had you pull out and staple the other day. So check your answers. All right, now it says justify your answer using a table of values. Every one of these problems, all you're going to do is use your calculator and either look at the graph or look at the table. All right, you don't need to graph anything. You don't need to do anything by hand. Just use your calculator and type these things in, okay? When you're done with that and you've gotten them all correct, I'd like you to go to the sub and ask them for that purple review packet, and you're going to begin working on that. All right, the answers to that are on Google Classroom, so please check that. All right, and make sure that you checked your homework from last night, which was the Classroom B examples. You had to do 1 and 2, the front and the back page, okay? Have a great day, and I'll see you on Monday.